Over the next 5 minutes, we'll build a simple JavaScript app, then compile its code for iOS, Android, Windows Desktop, Mac OS, and the web. To make this possible, we'll be using a new library from the Ionic team called Capacitor. If you've built hybrid apps in the past, you're probably familiar with Apache Cordova, which allows web technologies to interact with native SDKs. Capacitor is a replacement for Cordova that puts progressive web apps on the same playing field as native apps, so you don't need to constantly check which platform you're on. You just write your code once, and it should work across all platforms. If you're new here, make sure to like and subscribe, and if you're interested in building cross-platform apps, consider upgrading to a pro membership to get access to my Ionic Native with Firebase course. Before we get started, I do need to point out that Capacitor is just an alpha release at this point, so it's not stable enough to use in production, and its API is likely to change in the coming months. And one other thing to keep in mind is that this is a standalone tool, so you can use it with any JavaScript framework or just plain JavaScript if you wanted to. For this demo, I'm using Angular, but not the Ionic version of Angular, just a plain CLI app. Go ahead and open up the app in your IDE, and then install the Capacitor CLI. We can just copy the command from the docs and then run it from the terminal. That should install it in your project, and at the time of this video, we're running version 1.0 alpha 32. The next thing we'll do is initialize our app by running npx cap init, and you can give the app a name. Then the package ID is important for mobile apps. It should follow a format of com.brandname.projectname. The only thing that's doing at this point is adding this capacitor config JSON file to the root of your project. You'll want to go in here and change the web directory to dist, because in Angular we compile our code to the dist folder. Now let's make sure everything's working properly by building our app with ng-build-prod. Then we'll serve the app with Capacitor by running npx cap serve, and that's going to run it as a progressive web app in the browser. That should give you a default Angular app that looks something like this. Everything looks good there, so we'll go ahead and delete all the boilerplate code from the app component, and we'll build out a feature that requires interaction with native SDKs. A good specimen is geolocation data. Web browsers have one implementation, while iOS and Android have their own native SDK implementations. But because we're using Capacitor, we don't really have to worry about that. We write one piece of logic, and it ties all of these different implementations together. The app we're building is nothing more than a button that, when clicked, will show the user their current lat and long position. And it shows that using an alert dialog, which also needs to be handled differently based on the platform that code is running on. The first thing we'll do is go into the app component, and we'll set up a button here that runs this show alert method when clicked. Now, switching over to the TypeScript, we'll import plugins from Capacitor core. That brings in all the default plugins such as camera, keyboard, etc. Then we have a few things here from RxJS that we'll see in use later in the code. Then we'll go ahead and destructure the plugins just to the ones we need, which in this case will be geolocation and modals. In case you're not familiar with that syntax, it's just like saying plugins.geolocation or plugins.modals, just a little more concise. The geolocation plugin that we're working with here returns a stream of data, so whenever the user moves, it's going to emit a new geoposition based on wherever they moved. We can listen to the position with a callback function, but because we're working in an Angular app, it'd be better to format that data as an observable. So I'll show you a little trick here to convert a callback to an observable by using bind callback from RxJS. You pass the function that would normally expect a callback, and then that's going to create another function that returns an observable. So if you want to get the observable, you just call this function, and then you can pass in any arguments that were expected by the original function. The end result is that this watch variable is now an observable of the geolocation data. In this example, we're only interested in the latitude and longitude, so we'll pipe in the map operator and further map that object down to the actual coordinates. And now that we have a way of retrieving our observable, we'll go ahead and subscribe to it during ng-on-init. Whenever it emits a value, we'll use that value as the coordinates property on this component. So now we have our data in place. The last thing we need to do is create an event handler when the user clicks that button to show them the actual coordinate data. First, I'll set a couple variables for latitude and longitude, and then we'll use the modals plugin to display a different alert message based on the platform. You'll notice the message looks significantly different based on the device that triggers it. So that's the entire code for our app. Let's go ahead and do a production build with ng-build-prod. And then we'll add Android as a platform by running npx cap Add Android. This creates an Android folder in the root of the project, and if we open up this folder with Android Studio, we can click the play button and our app should run on a native emulator. Notice how we get prompted for permission, and the alert message looks significantly different than our progressive web app. Building for iOS is just as easy. We follow the same set of commands, just replacing Android with iOS, and we get a build that works on iPhones. Just 2 apps left, Windows and Mac OS. We can build these native desktop apps using Electron. So run npx cap add electron. That creates an Electron directory, cd into that directory, and install Electron Packager so we can build the binaries for Windows and Mac OS. Then run Electron Packager and specify Win32 for Windows and Darwin for Mac OS. And that'll put our app on 5 different platforms just in the nick of time. If we look in the folders generated by Electron, we should see one for Windows with an executable file inside. If we bring those files over to a Windows machine and open up the executable, we should have an app running on Windows just like it did on all the other platforms. So even though it's very early to be using Capacitor, it's something you want to have on your radar because it could potentially change the way hybrid apps are built in a very big way. I'm going to wrap things up there. If you have any questions, get in touch with me on Slack. Otherwise, make sure to subscribe to the channel, and if you're serious about building native apps, consider upgrading to a pro membership and taking the full Ionic course. You'll get access to a whole ecosystem of resources designed to help you build your app faster. Thanks for watching, and I'll see you soon.